Hello, today in this video I have a huge setup to show you how to wire up the EtherCat servo drives with the Motion4Sim controller. And first I will give you a small overview of the setup, and we start here with the Motion4Safe power hub included in the MK3 Plus set with the emergency stop. Then you have distribution wire system from the MK3 Plus system for the Ethernet. This is the connection bracket for the rig for all the wires and cables. You have power for the brake, power for the controller, and main power for the servo drives. Here's the distribution box, the power distribution box from the rig. It has several outlets for main power, the handheld controller, the Motion4Sim controller board. Then we have here a setup of two EtherCat servo drives with brake. And then we have, because we have brakes, we need this small PCB here for brake control with a servo driver logic and some patch cables and some cables for the power distribution for the brake. Yes, and finally here you see a commonly used AASD driver with motor, and we try to have them all running in hybrid mode with the Motion4Sim controller. Okay, now comes the intro, then we start. Okay, now let's start with the setup. First I will tell you, maybe if you have not seen the video, the unboxing of the AASD servo drive from OMC Stepper Online, you should watch this video. There I show how to wire the motor with the servo driver and the encoder and all the details. Then you can continue watching this video. Okay, let's start with the Motion4Safe power distribution hub. I already have done a video about it, and I will explain shortly again. Yes, you have connect this box to 230 volts mains power, and these two sockets you can connect your devices, your rig, and maybe other stuff. These two sockets are secured by the E-stop. Yes, it completely cuts down the power and is connected via this 12 connector here. On the other side we have two sources for DC voltage connected with this connector here, and this distributes 12 volt for the Motion4Sim controller and 24 volts for the brake. I will give you just a note. The brakes of a servo system, if you have a 60 UF with 6 brakes included, you will draw around 50 watts of power. We have installed here a power supply with 100 watt. Yes, here's a breaker and an energy meter. You will see later in action. So, okay, let's go up the wires for the power supply. This goes to the bracket of the MK3, and then we have here 3 volt, 12 volt power for the controller. I will plug inside here, and here we have the outlet for the 24 volts for the brakes. Next I will assemble these wires to the servo drives and show you the ready-made setup. Okay, I have connected the power lines to the servo drivers in this way. Okay, you have phase, neutral and ground. For the ground you need a small screwdriver to fix them at the ground connection of the downside of the driver, and then you can install the phase, which is brown, and the neutral, which is blue, in the slots for L1 and L2. You need also this small piece which comes with the servo driver. Okay, just install it and press it down, then you can insert the cable. So this is done for the two drives, and I have added here a connector to the brake wires so that we can connect the brake power supply later. So next we want to install the patch cables for the EtherCat data transmission, and you will wire this from the EtherCat master port at the Motion4Sim controller. This is this one, and from there you go to the first drive in port, and from the first drive out port you go to the second drive in port. You need no termination or anything else, that's all. If you have more drives, you just wire from the out to the next in until you're done. Okay, I will do this now. So we are nearly ready with the setup, but because we have brakes, we need to control the brakes, otherwise the motors won't move. So for this we have these small PCBs here, which controls the power and the logic from the servo driver. It's easy to install. Just plug it on the connector here for each driver, and then we have here this small BNC head, button head screws, for which you need an Allen driver of size 1.5, I think in my case. Maybe there are other screws available. And then I don't assemble them with the screws here for this setup, but in your rig you should fit them with the screws. Okay, then it's the same principle. We taking the 24 DC power from one driver with the extension cable. This is the power out to the next driver, power in. You can also switch them, and then you have only to connect the brake coils to each PCB. So, and that's the wiring for the brake. So now we have the setup ready and can start the system, I think. Okay, now everything is wired. Let's check again. The E-stop is connected, DC power is connected, mains power is connected, and the controller has his DC voltage. The servo is wired to the encoder, to the motor. The brakes are wired, and the Ethernet connection goes from here to there, and here are the motors. Okay, well, the setup is ready. I think now we can switch on the system. Okay, you see the energy meter is showing 12.111 watt power is needed actually. And let's test the emergency. Okay, I heard the brake switching off and the 24 volt power supply stays online because the brake power is also switched from the relay, but we need still some voltage left for the emergency button, which is driven by 24 volts. Okay, now I have released and it's going online again. So that's standby power needed by the servos, and without any motion enabled, controller has booted up instantly. I will restart it to show you the EtherCat boot up process. Let me look so you can read the display. Okay, now restart and power goes off. Restarts now. It takes a moment. Loading down our configuration, the EtherCat system. So now it's ready. I will show you what the drives are doing when we restart the system. And if I restart, they go into error state. And the system will be resetted when the boot up comes now. Okay. Then 18, 28, 48. And if the state is 88 RD, then the system is ready. Okay, now it's easy, just press the encoder. You hear the brakes releasing and the motors are turning. I have the AASD set up inside, and this fits, you see only small movement. Yes, okay, and when I give torque signal, I also reduce the values, it moves back, and then the controller is ready. I will show you a little bit more movement. A little bit tricky to catch the display here. Okay, now two actuators are ready. We press the encoder, then turning back to Servos, going right all the way to multi, and we take a high multi so that we have huge movement, and taking all actuators and then turning the encoders. Okay, now you can see that it's moving. Okay, alright, so it works, and that's the setup. In the next step I will show you how to handle this all in hybrid mode with the AASD servos also connected to the controller. But I see here in operation with two brakes released, we have 44 watts standby, and yeah, okay, I will do the setup for the AASD servo hybrid mode, and we continue then. Okay, now I have additionally installed the AASD servo. Yes, here's the motor, the driver, connected phase and neutral and ground, and the motors the encoder, and the DB25 cable connected to the controller. Because we have an EtherCat setup, it's at the moment, this will change later, so you can plug everywhere. Actually, we have only 8 slots in the telemetry data, which comes from the motion viewing programs. And for this first firmware, I've designed it in this way that you have number 1 is EtherCat drive 1, number 2 is EtherCat drive 2 in our case. Yes, if you have more, it will 3, 4, 5, 6, 7 for the EtherCat drives, and then possibly at the AASD. In this case, we have then to choose Actuator 3 for the AASD servo, which is stepped here. And then yes, that's it. And we just power up the system, waiting for the EtherCat servo process to initiate. And when it's ready, it takes a moment to boot up the controller. 28. Okay, 48 and 88. The EtherCat is ready now. The controller shows push encoder for homing is also ready, and then we push. So here you can see we have now 3 servos in preparing, and EtherCat 1 got homing, 2 got homing, and here also the AASD get pulsed, and here it's moving, also got this homing, and now we have 3 actuators ready. I will switch them online. You can see them moving, and yes, that it's hybrid mode on the Motion4Sim controller. I hope I can help you and show you all the stuff needed for the EtherCat. If you have EtherCat motors without brake installed, you do not need the breakout board here. You can just set up it without it. And yes, all in summary, quite simple. Thank you for watching. Bye.